Okay, so number one, this is a composite figure, so there's not a formula for the entire thing. You break it into the two familiar pieces and get the area, very simply. The rectangular shape is 13 by 9. It's a rectangle, it's length times width, it's a parallelogram, base times height, whatever you want to call that. So for the area of the rectangular shape, we're just going to have 9 times 13. I'm going to go quickly through this one because most people were okay with this one. And then for our triangle down there, we need base times height. And remember, your base and your height is always going to be perpendicular. So that is, I see the little box right there. So we're going to be using the 11 for sure, and I need to know this value right here. I look over to the rectangle and I see that the entire area is, or the length is 13, but 8 of it's up to right here. So if the whole thing's 13 and that's 8, that leaves 5 for that missing, we can call that the height of the triangle. So we do base times height divided by 2. So for the triangle, it's going to be 5 times 11 over 2. And you'll crunch the numbers on that. You'll do the math. You'll get an area for the rectangle, area for the triangle. We add those together, just like you did with your house projects when you're designing your floor plans. You added all those up. Same thing. That gives you your total area. Okay. Okay. For number 2, first, this shape is a parallelogram. So we're going to use base times height. The base is going to be 38 up top, and the height is going to be the 29 right there. So very simply, it's 38 times 29 equals your area. I'll let you crunch the numbers on that one. No big deal. Number 3 is a graphing problem. Some people try to graph on the page itself, and I had graph paper, so I just had everyone grab a half sheet of paper when I was here, and we graph the points. That's what you want to do on the test. Take a look at it. If the shape had been diagonal, if the was something like that, the x and y were still in the same spot, but the picture was diagonal, you'd have to use the distance formula to figure out your base and your height. But this one's very straightforward, so we just use it as is. We get back to normal. I graph the points, and I'm using right here as a base, and then this is another base up here. So your height is the distance between bases, opposite bases. So I built a little imaginary triangle out here, over here. So from this level up to this level is a distance of 4. So that is my height. The base is 2. This problem is really just 2 times 4, and call it a day on that one. Be careful. A lot of people on parallelogram problems are doing base times height divided by 2. That's triangles. So this is just 4 times 2. Okay. Number 4, the kite has diagonals. It's a kite. I mean, you could draw a picture of it if you want to. Got diagonal. That looks more like a rhombus, but use your imagination. It says diagonals are 6.7 and 6. Okay, it doesn't say half. It says the diagonals are. It's giving you the diagonals. The formula is d1 times d2 divided by 2 equals your area. If it was half of a diagonal, it would clearly state half of the diagonal is whatever. It doesn't make sense that some of you were calling it halves. If I draw the proper thing right here, this is what a lot of you were doing on the test. So this part right here that I'm going to do is wrong. Let's say I call this 6, and then I call this 6, and then I call this 6.7, and I call that 6.7. Okay, if you were doing that on the test, you don't know what a kite is. 2 sides are short, 2 sides are long, right? For the diagonals, the 6 and the 6 would be correct because the short one is bisected by the longer one, but the long one is not cut in half. That would be a rhombus, and that can't be a kite. So it just didn't happen. So they're giving you the entire diagonal. Don't do it half, the whole thing. If it's half, it will say it's half, or the picture will be on one side. So you really just have to do 6 times 6.7 divided by 2, and that's your area. It's a simple little problem. Just take it for what it's worth and get your points. Okay, number 5 has an isosceles triangle. I had a lot of trouble on this one with students, and but I'll walk you through it. So I'm going to draw an isosceles triangle first, so something like that. And they give me the area is 150. Okay, I got a base of 10. That's great, right there. Boom. Okay, anytime they give you an area, the actual number, you're going to be working backwards. You're going to be solving for the base or the height or something like that, finding something out. So I'm just going to write the formula for area of a triangle. It's base times height over 2. Everyone knows that. I'm going to plug in what I know, and I know that the area is now 150. The base is 10, and I don't know the height on this one. That would actually be like right here. I don't know what that is. So I'm solving for h, right? Multiply both sides by 2, or I can just cut the 10 in half. It doesn't matter, whatever floats your boat. I'll just multiply by 2, and I get 300 equals 10h, because the 2's cancel. Divide by 10, cross off a 0, so I get h is 30, right? Not the answer. So then what I do is I take the triangle, and for this test, for this study guide, for this whole unit, anytime you can drop a line straight down and be perpendicular to another side and you can make a right triangle, it's probably a good idea to do that, because we can solve right triangles. We've got trig, we've got special rights, we've got Pythagorean theorem that we can do. So we've got 3 different things we can use to find those out. So I'm gonna cut this triangle in half, and it's an isosceles. So when I drop this line down here, this guy right here, that's an altitude, and that is an angle bisector. It is it bisects the base, it cuts it in half, it's perpendicular to the base. It does everything. So that is a right angle. If the whole thing was 10, this is actually 5. That's not always the case. On most triangles, that's not the case, but isosceles from the vertex, equilaterals, it does do that. And the height was 30. I can write that in. And the whole point was to find the legs, and that would be this guy right here, this guy right here, that guy right there. So what I have right now, I'll let you finish it up. I have two of 3 sides of a right triangle. That is clearly Pythagorean theorem. The hypotenuse is this guy right here, so you got to make sure that that is your C. So 5 squared plus 30 squared equals x squared. A lot of people are not putting the x squared, everything squared. You get your 25, you get your 900 equals x squared. It doesn't go away. It doesn't go away until you finally take your square root, and you're rounding to the nearest tenth. It says so you're going to get a decimal on this one. Okay, moving on. Okay, number 6. We practiced these a bunch, and this is a rhombus. It even tells us a rhombus. And if you know about rhombuses, you've been paying attention, you know that the diagonals bisect each other. So I'm going to blow this up a little bit. Here we go. Blow it up a little bit. So if this is 8 right here, then this is going to be 8. And then these two are going to be the same also. Whatever, the top is, the bottom's going to be. The diagonals bisect each other. The diagonals are perpendicular, so they're all right angles. So we get a bunch of right triangles. You should see that 60. You should know that this is a 30, 60, 90. The 8 here is across from the 30, so that's the small side. To get from the small side to the medium side, I'm going to multiply by radical 3. So that is 8 radical 3. So for diagonal 1, let's call that my 8s. It's going to be 8 plus 8, so 16. For diagonal 2, it's going to be 8 radical 3 plus 8 radical... Oh, there we go. 8 radical 3. Hang on, didn't take that one. Make that a little bit smaller. So 8 radical 3 and 8 radical 3. Okay? Remember that if this is 8 radical 3, this is 8 radical 3. So that's where that extra one came from. A lot of folks are confused on this one. The radical 3's work like variables. Just think of them like an x. If you have 8 x's and 8 more x's, how many x's do I have? You get 16 of them. The x's don't change into y's or x squares or anything weird like that. The radicals work the same way. You can only change a radical if you are multiplying or dividing. So by adding, it just stays the same. It's kind of like saying I have 8 radical 3's, and then someone gives me 8 more radical 3's. How many radical 3's do I have? It's just simply 16 radical 3. Okay, so I have my diagonals. The formula is d1 times d2, so I'm simply just going to go 16 times 16 radical 3 divide by 2. I'll let you do the math on that, but that's how you do it. Okay, number 7, area of an equilateral triangle. So the first thing I'm going to draw is an equilateral triangle, or something close to that. Let's hope for the best. Not too bad. And we learned all about triangles last semester. You should know that equilateral means equiangular, and inside angles for any triangle add up to 180. So because the angles are all the same, they share 180 equally. So all of these are always going to be 60-degree angles, only in the equilateral. All the sides are going to be the same. So if one is 8, they are all 8. Okay. For the area, we could actually be done right now. We could do the shortcut. I'll show you the trig route too. I mean, technically, we could do side angle side right now. You could do 8 times 8 times sine of 60, cut it in half, and you'd be done right now. I was telling people in class to do the trig route or the special right route. That's all good. So to do the special right, we'd have to kind of cut this guy in half, a little chainsaw right there, and we get something like this with a 60. Half of this would be 30, and that's our right angle, and that's 8. So we walk the dog on this to go from the long side to the short side. We cut it in half, so that's 4. To go from the short side to the medium side, that makes that 4 radical 3. So our height is 4 radical 3. A base would be a full 8, and so we're going to plug in base times height divided by 2, so 8 times 4 radical 3 divided by 2. So we get 8 times 4 is 32 radical 3, and then just cut that in half, so 16 radical 3 would be your final answer. Units, it doesn't say anything, so unit square, something like that. Number 8, man, super straightforward. You have a base, you have a height, just plug them into the formula. 5.4 times 7 over 2 equals A. Done. Number 9, again, anytime they give you the area, you're going to be working backwards. So start with the formula, A equals BH over 2, and then do a substitution. Plug in everything you know. You should know everything but one thing, and then that's the variable that you solve for. This is an algebra question purely. 26.4 equals, the base is 12 in this case, and we don't know the height, over 2. So you just work backwards on this one. You could go ahead and divide right now and get that into a 6. 26.4 equals 6h, and then just divide both sides by 6. I'll let you finish the math on that. That's not real exciting. Remember, your answer is going to be in yards, not square yards, because this is not, your final answer is not an area. Number 10, it's made for the shortcut, so we're going to use side angle side. So anytime you have a triangle of any kind, right or otherwise, and we have 2 sides in a row, consecutive sides, and the angle between them, you can use a shortcut. So it's simply 7 times sine, always sine, of 148 divided by 2, and your calc can crunch the numbers on that. Done. Number 11, very straightforward. This is a trapezoid. Man, I got so many kids that can't tell the difference between a rhombus and a parallelogram, a rectangle and a trapezoid, and you're just in trouble if you can't do that. You have to know your shapes. You have to know what makes them that shape. You've got a whole sheet in your notes, a solid one of everything about quadrilaterals. You should really know that sheet. We did it last semester. I've talked about it this semester. You need to know those for this test. Okay. We have a simple formula. It's and I'll never forget it. It's because I have 2 bases that are different lengths. I've got a short base and a long base, so I need the average, the mean. And then average, a mathematical average, is when you add those numbers up and divide by how many numbers there are. So I'm going to add up my bases, B1 plus B2, and I want the average over 2, right? And then I'll multiply that by the height. It's just it's a version of base times height, right? But I have to get the average of the b's. That's the B1 plus B2 divided by 2 part, right? So simply that, it's 3.5 plus 7.1. Go ahead and add those up, divide by 2, and then multiply that by 5. The 5.4 is meant as a distractor. You don't need that number. And that'll be your total area, so miles square on that. I'll let you crunch the numbers. Number 12, again, they give you area. Anytime you give an area, you're working backwards. So start with the formula. So I have just what we did last time. Area equals B1 plus B2. A lot of people are trying to put multiplication in there. It's an average. We add them up. Know why we do things, not just rote memorization there. And then times the height. Okay. So it looks like the height we're going to be looking for is right here. That's the one we don't know. 5.2 is a distractor. We don't use that number at all. So instead of A equals, I know the area. It's 31.5 equals. One of the bases is 8.9. Another base is 3.7. I'm going to add those two numbers up, divide by 2, right? And then I'll rewrite that as some number of h. Add them up, hit equals, and then hit divide by 2, and you'll get some number times h, and then you just divide both sides by that number. I'll let you crunch the numbers. Easy problem. Okay, that is a dotted line. I had a lot of people trying to turn that into like a trapezoid and a triangle. That is just a parallelogram. It is simply base times height. So I'm sorry if the dotted lines are not super clear on this thing right there, but those are dotted lines. So it's just 4 times 7. That's all. And inches square on that one when you're done. Okay, again, they give you the area, so we're working backwards. So it's base times height. Looks like we don't know the base. So 50.4 equals 6b. Divide by 6. I'll let you do the final numbers on that. And that would just be inches because it's not an area. The answer that we're looking for is just a side. So 50.4 divided by 6. Area of circle. Area is pi r squared. Area is squared, so we have the square r. Whoa, that's ugly. We have the r squared on there. Okay. So the radius is 5. So we're just taking 5 squared and slapping on a pi. We're going to keep the pi as the symbol pi. So 25 pi in its kilometers squared. Some people I've seen put squares on the pi symbol itself. Never do that. Pi is pi. And that's it. Circumference is, since we have a radius, we're going to use circumference is 2 times pi times r. So really 2 radii, or 1 diameter. So 2 times 11, really, is going to be 22 pi and yards. And this is not squared. It's not area. It's just circumference. It's kind of like perimeter. If a circle had a perimeter, it's the distance around the circle, but 1 time around. Okay. Another teacher saw this question, giggled hysterically, and said, "Please leave this on the test. We're daring you to miss this question." And I've had several folks ask me what the formula for diameter is, which means you don't know what a diameter is, and you need to know that. We talked about chords in class, and we're going to get way more into this in the next chapter, but on the intro lesson we did talk about chords, and I did mention that the diameter is the longest chord. It goes through the center. And so if a radius goes halfway, the diameter goes all the way across. So if a radius is 2, then the diameter is just twice as big. So literally 2 times 2, the diameter is 4 inches. There is no formula, it is. If you know the radius, you know the diameter, it's twice as big. If I give you a diameter, the radius is half as big. It just is. You need to know what that is. Okay, we're back to half of Pennsylvania, my favorite. So they give us the perimeter here. You have to have some kind of length. A radius, an apothem, a side. Perimeter works great. Perimeter's in the formula. That's the capital P. So I'm halfway there. I just need the apothem. When they give you the perimeter, they're giving you the sides of the polygon. So all the sides are the same, remember that. And if they're all add up to 20, there's 5 of them, that must mean that each side is 4. So when I rip my triangle out, it'll be 4 right there. When I cut it in half, that's going to be a 2 right there. Okay. I find my central angle, this thing right here, and it's going to be 72 degrees. That's 360 divided by the number of sides, in this case 5. 360 divided by 5, sorry about that, 5. And then when I cut it in half, I'm going to use 36 degrees, which is half of 72. Okay? And all this work is going to be done to find the apothem so that I can make my formula work. I've already got the P, and I just need the A. So, solving this triangle right here, that's going to be where my trig comes in. I'm using, looks like opposite adjacent, that's tangent, so the tangent of 36 degrees equals 2 over A. That's the annoying one. So I have to multiply both sides by A. A tan 36 equals 2. I divide both sides by tan 36. And that's going to give me my apothem. 2 divided by the tangent 36. I've got the apothem. I've already got the perimeter. I multiply them together. And I divide by 2. Don't forget that. Half of Pennsylvania. And that's your answer. Rounding to the nearest tenth. Tenth is 1 decimal place. Okay? This is a parallelogram. It's a tiny one. And again, they're giving us the area, so we're going to work backwards. So we're using just base times height equals area. Plug in what I know. Looks like I've got a base of 7, h of I don't know, and that is 14. So just divide by 7. Okay, 22. This one's kind of weird, but it's a triangle, and this is under the heading of regular polygons. So this is a regular 3-sided polygon, which means it's not just any old triangle, it is an equilateral triangle. Because remember, regular means all the sides are the same and all the angles are the same. So again, like I did way earlier, this is going to be equiangular. They're all 60s, right? And let's see. There's the bell. Okay. For sake of time, I could just do the shortcut. All the sides are going to be 9 radical 2 over 2. So I could just do side angle side. I can multiply 9 radical 2 over 2 times 9 radical 2 over 2, and that would give me 81. Radical 2 times radical 2 is radical 4 or 2, right? So I can let my 2's cancel. So that would be 81, to make it a nicer number. Sine of 60 degrees divided by 2 would be the total area. That was using side angle side. I did this math right here just so you had a nicer thing to type into the calculator. Get you that, turn that into an 81 for you. And that'll work. If you did it the long way, I'll just get you started on that. It means that we had to go in here and start with the center point and get my central angle. And inside of this thing, I can have only 3 triangles, so that means that central angle is 120. And then this would be 9 radical 2 over 2 down here. And I'd rip out the triangle, I'd cut it in half, and I'd do all the normal steps that I normally do. And that's the study guide.